question is, two random processes x of t equals to a cos of omega t plus theta, y of t is a sin of omega t plus theta, where a and omega are constants and theta is uniform random variable over 0, 2 pi. Choose correct statement. Here from the properties of cross correlation function, here Rxy of tau minus tau equals to Ryx of tau is the correct one. Hence option A is correct. Is a binary system uses the pulsed waveforms f of t equals to f1t and f2t. f1t is nothing but a sin of pi t by t, whereas t is in between 0 to t, and f2t is 180 degrees shifted version of f1 of t. Determine the probability of error. Let a equals to 0.14 millivolts and t is 2 microseconds. Additive white Gaussian noise with a PSD eta by 2 equals to 10 power minus 15 watts per hertz is added to the signal when probability of S1 equals to probability of S2 equals to half. We know that the probability of error PE is given by, for this is Q under root A square T by eta. A square T by eta is nothing. If we substitute the given values, then we will get this as 20, approximately 20. Hence it is Q of 20, hence option A is correct. Question is, consider a half wave rectifier using capacitor filter fed by a 60 Hz sinusoidal having a peak value of 100 ohms. The value of capacitance that will be required in peak to peak ripple of 2 ohms for a load resistance of 10 kilo ohms is. Here we know that in case of an half wave rectifier using a capacitor filter, the capacitance equals to peak voltage divided by peak to peak ripple into the frequency into the resistance. If we substitute the given values, that is then we will get this as 83.3 microfarad, which is option D is correct. Is power dissipated in the 5 ohm resistor for the circuit below is. Here if we apply, that is VA minus VB is 10. Okay, now next VA, this is equation 1, VA plus 12 VB is 30, this is equation 2. If we subtract second equation from 1, we will get 13 VB is 20, that is VB is 20 by 13. So I is current through the 5 ohm resistor is VB minus 5 by 5 ohm resistor. So P is I square into R. Then we will get this as 2.4 watts. Hence option B is correct. Question is, a 4-bit resistor network based D2A converter is shown in the figure. The output corresponding to the number. Here 1010 is the input. Means MSB switch is closed as well as the second from the LSB switch is closed. So the current is, this current is nothing but this current. Here I is 10 by 10k plus 10 by 40k. So V0 is minus I into 5k, because this is the polarity V0 is from here. So 1 milliamp plus 0.25 milliamp 1.25 milliamp into 5k. So that is 6 minus 6.25 volts. Hence option B is correct.
Feedback system is shown in figure and its root locus of its characteristic equation is drawn like this. Okay, now here first question is, if point 5 minus 5 comma 0 is a point on the root locus, the variable parameter k of the system at point P is. Okay, see here there are 2 poles and 1 0 in this root locus characteristic equation. Okay, now what is this open loop transfer function of this root locus? It is given as k times of, there are 2 poles, so at pole at -1 and a pole at -2 and a 0 at -3. So this is the overall open loop transfer function of this system. Okay, now we have to check whether -5, 0 is a point on the root locus or not. Okay, there is a condition that if a root locus branch is represented like this, what does it mean? That it means that this branch is on root locus plot. Okay, to satisfy this branch to be on root locus, we should have 2q plus 1 into 180 by n minus m. Okay, what is this one? Odd number of 180s present on this branch. Okay, now to satisfy a point on the root locus, it should satisfy magnitude condition. This is what? Angle condition for root locus branch. What is magnitude condition? Magnitude of transfer function, that is CRF into R of S, which is equal to 1. Okay, now what does it mean? That at S is equal to -5, this condition should be satisfied. This is plus 1. Okay, now substitute this one. At S is equal to -5, so this is -5 plus 3 into -5 plus 1 into -5 plus 2. Magnitude is equal to 1. From this we will get K as 6. Option is C. Okay, now next one we have to find is, for a unity feedback system shown in figure, the root locus of the characteristic equation with variable parameter k equal to 2. What is a closed loop transfer function? We found that open loop transfer function is, that is CRF by R of S, which is equal to k times of S plus 3 by S plus 1 into S plus 2. Now in question, he has given this variable parameter k as 2. Okay, what does it mean? That this is 2 times of S plus 3 by S plus 2 into S plus 2, which is equal to G of S. Now what is closed loop transfer function for unity feedback system? G of S by 1 plus G of S. Okay, so this is 2 times of S plus 3 by S square plus 3S plus 2 plus 2S plus 6, which is equal to 2 times of S plus 3 by S square plus 5S plus 8. Okay, so option B is correct answer.